graph f of x equals 2x cubed over x plus 1. This is a rational function, and there's going to be a funky asymptote because the degree of the numerator is bigger than the degree of the denominator. So let's first find the asymptote. That's really the most complicated part. The way I do that is by dividing. I'm going to long divide 2x cubed by x plus 1. And when I do that, you could actually, on this one, you could do synthetic division, but don't get in the habit of doing it. If you want to do synthetic division, that would work because this is a linear factor.
Function, yeah.
But let's just do long division because you're going to need to do that anyway. So how many times does this go into this?
2x.
2x squared times. And when I multiply that here, I get 2x cubed, thank you, plus 2x squared. When I subtract that, distribute the negatives in, I get negative 2x squared. And how many times does this go into this?
Minus 2x.
Goes into it minus 2x times. Very good. When I multiply that, change colors. When I multiply that here, I get negative 2x squared minus 2x. Distribute the negative in. That goes away. I get 2x here. How many times is that going to 2x?
Wait.
How'd you get 2x?
How'd you get 2x?
Isn't it just 2?
Isn't it? Yeah.
Nope, it's 2x. Let me go back and you'll see that. 2x times x plus 1 gives you 2x squared plus. Let me
Oh,
erase
because
that.
it's the x plus 1 and
Yeah.
that. Okay.
When I distribute this negative 2 back in, I'm multiplying this by
the 1.
both of those.
Oh.
Negative 2x squared minus 2x. And now I have to distribute, I'll change colors, the negative in. Those become positive. That's why that cancels.
And then it's
this
like
is
plus
now
2x.
positive 2x. How many times does x go into 2x? It goes into that 2 times. Positive 2 times.
Oh, yeah. So 2x
And when I multiply that
plus
through,
2
I get
minus
2x plus 2.
So
they
it's negative
subtract
2.
them both, and the remainder is negative 2. That doesn't really matter. This is what matters. That's our
oblique asymptote.
That's our asymptote.
Oh,
So 2x squared, it is probably an oblique one. It's an oblique asymptote. It's not a simple.
Slant.
It's not a slant asymptote, and it's not a simple
Horizontal
line. It's a crazy asymptote. So that's my asymptote right there.
So 2x squared minus.
Beyond that, I also need to find my any vertical asymptotes that I have, and that comes from this right here. So my vertical asymptote, my VASI as we call it, is x equals negative 1, and my x-intercept comes from setting the top equal to 0, which is just 0. So I know it goes through 0, 0. I know there's a vertical asymptote of negative 1, and I know there's a oblique asymptote of that quadratic function.
Can you?
And so let's do that. So let's take a look at our vertical asymptote. I already have it on there. My horizontal asymptote, which is right there. Let's draw that in. The quickest and easiest way to do that is to find the vertex, which is negative b over 2a, which is positive 2. That's negative b all over 2a, which equals 1/2. So the asymptote's at 1/2, comma. Now plug in 1/2 into here. You get 1/2 minus 1 plus 2, which is 1.5, right? Is that that's my vertex of my vertical asymptote, and now plug in another number, like 1. Plug in 1 and plug in, well, you know that 0 will be equal to that, so plug in 0, I guess that's even easier. Plug in 0 and you get 2. That's the y-intercept. So go 1/2 over to the other side and you'll get to that same point because you know it's symmetric. And it's going to do some. Let's plug in one more thing. Let's plug in negative 1 to see where this asymptote crosses, the parabolic asymptote crosses the vertical asymptote. When I plug in negative 1 into here, I'll change colors. When I plug in negative 1, I get 2 plus 2 plus 2, which is 6. So 2, 3, 4, 5, 6. It's up here somewhere. I'm running out of space. Let's pretend like that's 6 up there. I know it's not, but let's pretend like it is. and I went over 1.5, so if I go over 1.5 on this side, it's also going to be there. So my graph is going to be like this. Now, I didn't do a very good job graphing it because I'm really going to need to graph up here in that quadrant up there where those intersect is where probably my graph is going to exist. But down here, my graph exists. The x-intercept, I'll do the graph in red. The x-intercept is 0, 0, right there. And I know it approaches down that way, and over here it comes up and approaches that asymptote like
and
that.
that's using the number line method, right?
You can plug in points to see
okay.
that that's going to do that, but you know, look, if you think about it, it can't be going up here
Because
because then it would be forced to cross this vertical asymptote, but you can't ever cross a vertical asymptote. You can cross a horizontal asymptote, just not a vertical asymptote. And then if by plugging points into this, well, actually, I know it's going to have to be up in the top quadrant. So let's zoom up there. Let's pretend like that section right up there. Let's put it right over here. There's your asymptote, and there's the parabolic asymptote right there. There's my vertical asymptote, my parabolic. I know it's got to be up there because if it was down here somewhere, it would cross the x-axis again, but I know there's only one x-intercept. So it's got to be up here. And that's what your graph's going to look like.
Wait, how did you know it was inside the...
I knew it was inside this area. Let me create a new picture here for you. So there was my one asymptote, there was my other asymptote like that, and I knew I had a 0 over here, and I didn't have any other zeros. On the left side of here, it's either going to be somewhere in this region, or it's going to be somewhere in this region. There's no other option for it, and it can't be in this region here, because if it was, it would be approaching that asymptote to negative infinity, and you would have had an x-intercept. But I know there's no more x-intercepts, so I know it has to be in there, unless it's really funky, but that's not extremely funky of a graph, so that's just a pretty typical rational function. So that's how you know that works, and hopefully that's clear for you.